Good evening, everyone. This is Jishnu from Pantech Learning. Today we are going to see regarding towards 5G communication, how to implement the simulation in MATLAB. So I thank Broadcast Engineering Society of India for providing this opportunity to share the knowledge of 5G communication simulation. So we will be completely working regarding towards OFDM techniques with IEEE wireless waveform generator module as well as OFDM simulation with PSK simulation as well as QAM simulation. So let us start the session now. So before starting the session, we will be just going towards a glance of Pantech company. So we have origined in the year of 2004. We have 7 branches and 100 plus employees. We have conducted more than 1200 workshops. We also had crossed more than 100 webinars. We have our own R&D at Sholingnallur, Chennai for industrial projects. We also conduct faculty development programs, hands-on training workshops, internships and in-plant trainings, short-term courses and value-added courses. We also conduct academic project training, customized design services at the state of R&D. At recent, we have also started the procedure of working regarding towards small developments as well as small training courses towards the high school level children. We have been expertised in these domains such as Internet of Things, Artificial Intelligence, Embedded System or Robotics, VLSI, FPGA, TMS processor, image processing using OpenCV and MATLAB, network simulation, wired or wireless, power electronics, electric vehicle, big data and data analytics, Internet of Things, Python, Android application development, data image text mining, cloud computing and mobile computing. So generally we work regarding towards each and every technology whatever we see for day-to-day our lives, like Internet of Things, Artificial Intelligence, embedded. So like that even communication is also being upgraded whenever we see from the past 20 years. So whenever we work regarding towards this communication, earlier it was only the message sent with the help of some PGN, and then later on with the post mails. Then comes with the telegram for quick messages. Then comes with the electronic device as pager, internet facility for sending mails. Then comes with mobile phone for instant communication. So within that mobile phone itself, we have various kind of communication like first it was voice call, then going with the voice message as well as text message within the mobile. The first generation is known as 1G. Then comes with 2G starting to access internet in our mobile. Then gets upgraded towards 3G known as WCDMA. Then comes with the 4G. So this each and every communication level has been implemented. And what are the other communications other than this particular generation development? Like RF communication, Bluetooth communication, Wi-Fi communication, LoRa communication and Li-Fi communication. So these are all completely comes under the technology fields. So when we compare to the two different models, OSI model as well as TCP/IP model. So in OSI model, there are separate blocks for each and every kind of process according to whatever we do in a particular organization. But TCP/IP model is a particular kind of a current application or whatever we are working it on, as well as we all are one of the client for each and every application in each and every different ways of working. Like if it comes for the application block in TCP/IP model, embedded as well as Java Android application like embedded systems using in form of laptops, computers, mobile phones, televisions, etc. The Java and Android then comes with .NET for each and every softwares whatever we use it for. For example, Android applications, Java applications, and we are commonly used in mobiles as well as laptops respectively. Then comes with networking. So whenever we start with networking, how it is working in transport as well as internet. So internet for long distance communication like video call, and it is used for education in nowadays, and many of them are writing exams also through internet. And transportation is nothing but sending a huge amount of files through internet itself, and from a remote place it is as easy as possible. Then signal processing. So whenever we work this kind of different modes of communication, definitely there will be some interference between them, some sorts of interruption. So that interruption can be set as unwanted signals, and for that commonly they are called as noise. So for that only we will be applying this kind of signal processing for each and every application whatever we use. So for that only we will be applying the digital signal processing technique, which can be simulated with multiple kind of software tools or hardware tools. So when we talk regarding towards the software tools, some of the software tools used for digital signal processing are MATLAB, Python, and LabVIEW. Even we can also go with Texas Instruments kind of devices, and mostly DSP processors, whatever we use, it is completely made with the help of Texas Instruments. So whenever we work regarding towards this digital signal processing, what are all the various fields that gets implemented over here? Those are communication, image processing, antenna design, audio processing, and video processing. So these kind of different applications only we will be just working regarding towards the functions. So now let us check what are the different wired and wireless types of communication. So here wired communication comes under the twisted pair, coaxial, and optical fiber. The twisted pair as well as coaxial are mostly used for the communications of landlines, and optical fiber is mostly used for broadband connections of internet. So definitely these are completely wired, and they can be transformed into the wireless only toward the particular kind of different perimeter level. So in what way, if we just apply the landline connection with the help of the codeless system, that whatever we have been provided over in our home, that can be just in and around within the home only we will be able to talk. Then when we go for this optical fiber, at maximum we will be able to provide a Wi-Fi for a wireless connection to access all the devices in our home. But when we go for the wireless, we can go with terrestrial microwave, satellite microwave, and broadcast radio. So here, broadcast radio just completely goes regarding towards the radio stations as well as broadcasting towards our TVs with the help of dishes. Then the satellite microwave, it completely stands under the function of regarding towards working for each and every kind of application like mobile phones as well as wireless net connections or transmitting of the data. Yeah, please check your network speed. Regarding to your network speed only, the clarity will be displayed. And here also I have side by side represented in the form of this mobile itself, but I am able to view as clear. So please check your internet connection. Okay, so this terrestrial microwave are mostly used for the particular kind of Navy, Air Force, or the Police Force, whichever they are using it under the functions of the radios or commonly set as walkie-talkie. So the broadcast radio is the one view, and whenever we go for the terrestrial microwave, it is dual wave of input. So here for broadcast radio example, I can give you this as a particular kind of example. Whatever we are currently moving on with YouTube, you are allowed to just provide us a comment or the live chat until the session is going on. But whenever if we go for the communication regarding things, therefore it is not possible to do with the uh, through voice oriented kind of communication. Only one way. Those who are particular person is broadcasting, only he will be able to talk with the help of this kind of application. So what are the different evolutions? So this evolution only initially I have explained regarding towards us 1G, 2G, 3G and 4G. So whenever we go for this particular kind of different evolution, what will be the difference? Is it possible to generate a kind of waveform according to the devices whatever we require? Yes, it is possible. So today's entire session we will be going with the help of MATLAB only. So this 1G, 2G, 3G and 4G is everything differs only regarding towards the speed, right? So initially we were having 2G network connection, and that time we don't use much of mobile net when we have the broadband or optical fiber connection. Not optical fiber, mostly coaxial that has been taking interruption from the landline towards the PC, whichever we were using. Then once the mobile has been updated towards a smartphone, they have increased the particular speed known as 3G, completely known as WCDMA, and within that we are having another one option known as HSPA plus, also known as 3G plus system. Then hence it upgraded towards the 4G, which is about of 1 gigabyte of speed, which we are currently using, known as LTE, as well as long term evolution. So through this long-term evolution, we have another one option known as Vivo LTE, voice over long-term evolution, nothing but communicating through long-term evolution signals. For that only we are calling as voice over, through which we will be able to make a voice call. Whereas there was no such options in 3G and at the same time of 3G plus. So whenever we go for this kind of particular applications, therefore we will be just seeing how that waveforms can be generated, and what will be that particular numerical value, and how each and every testing kind of functions are being applied over there. So for that, here I am choosing the common MATLAB only, and within that MATLAB we have to just select the respective 4G LTE waveform generator. So here we have a test model generator, and before that if you want to add packages towards this particular MATLAB, you can go to the add-ons, and here I am using MATLAB version of 2018B. So it just take time in order to open it. Yeah, so finally it has been opened. So within this we can select the toolbox whichever we require and click on installation. The only requirement is you have to just install the MATLAB toolbox with the help of your mail ID. So here if I type LTE, therefore that current app whatever we are using LTE toolbox, like such decode or wireless HCL toolbox, everything will be there. And for 5G we have to install separately to simulate, analyze and physical layer. So if you want to just check what and all present within your toolbox, you can go to this and you can search for the functions. So based on this particular carrier configuration only, we will be working towards the app. So this particular 5G waveform generator is completely worked as a wireless waveform generator by combining both OFDM analysis as well as implementing towards QAM, PSK, and at the same time we will be applying this OFDM with 802 series of IEEE hardware. So therefore we will be able to simulate multiple kind of OFDM signals. Even you are also available with some of the examples where you will be able to work with the help of 5G toolbox. But better than towards this working of coding section, it will be more interesting and it will be much more easier to test a small amount of data with the help of the app. So make sure before you just work regarding towards this 5G to install all your required toolboxes. Okay, so now let us go into the app section, and from this app section I'm going to operate this LTE test model generator. So within this test model generator we have this as the parameters. So the test model we will be taking it as 1.1 or 1.2 according to our basic section. So whatever I will be showing, it will be in the form of basic only. So within this model of 1.1, we will be applying that bandwidth of the signal communication as 1.4. So the basic one is known as the 1.4 in size of megahertz, and above that we have to go regarding towards the RV section. So then we have to just define how much number of cells we have to apply it over there. And here regarding towards the cell, we are keeping it as single cell only. Then we have to select what kind of mode we are going to apply, especially in duplex mode. So this is nothing but frequency domain division and this is time domain. So here we are basically applying regarding towards the frequency, because all the signal will be working only based on the frequency level. So mostly whenever we go for the signal strength or tower location, everything will be based on the frequency. So according to the frequency only we will be able to convey all the data which we require, either image, voice or live calling, everything. Then number of subframes that has to be applied for each and every bandwidth. Here it has been applied for 10, and the windowing samples, the basic samples will be initiated from 0 only. So the waveform output will be stored in this particular variable, so we have to provide a variable over there. Then resource grid output also will be stored in the grid variable, and ETM configuration, nothing but electronic function of configuration, is also available at this particular variable. So these each variable will be exported towards our workspace. From that, the tabular column we will be able to analyze it, which is present in the form of .mat. So this complete is a basic of LTE simulation. Then only we will be able to work with 5G, so that we can make it as a comparison section. So now click on generator waveform. Please wait for a while till it gets generated all the values, and we can see it over here. So after this, with the help of the downlink transmitter value, we will be able to analyze so how it was able to generate over there. So this will be nothing but known as the 4G generator value, which left hand side is known as the real time value and right hand side is known as the imaginary value. So this right hand side as well as left hand side imaginary and real value will be applied towards the graph. So regarding towards that particular plotting, we will be able to see it as a time scope analysis for each and every signal transmission. So here we won't be able to plot as this is a raw data over there. But whenever if we go for the 5G simulation, it can be rawly plotted as easy as possible towards the system. Okay, so before going to that particular 5G, we have to know what are the different types of signals and why we are moving towards the 5G with the help of the OFDM as well as cognitive radio networks. So before that particular kind of introduction regarding towards it, so why we are going with multiple domains of signal processing, it is none other than it depends upon to the each and every function. So this function is known as the FDMA type of signal, frequency division multiple access. So based on the frequency, we will be able to access as multiple as possible. So for this example, I can provide you as a radio system. So whenever we just hear regarding towards this 93.5 FM, it is accessible at all the states based on their regional languages, but the frequency value will be same. So it depends upon the particular kind of FM frequency or FM station. So each and every frequency whenever we access, therefore that particular radio station will be applied over there. But here there is an issue. This radio station cannot be completely related towards this FDMA. So when we go for more accurate, we can go with our walkie-talkies, because each and every walkie-talkies will be able to access only with the help of the frequency. But if you want to go with that particular kind of application of a radio, then we have to just switch it over towards FDMA with TDMA. So when we combine both FDMA and TDMA, it works for both broadcasting technique, like we can go with this TV serials, and we can go with our TV broadcasting as well as radio broadcasting. So why and how the process will be explained in detail. So before that particular explanation, we also know with TDMA as well as with FDMA. So first we have seen only the FDMA. So according to that particular FDMA, the ratio proportion is done with the help of power as well as the frequency slots. So here the power value is nothing but the power supply provided towards the complete device, and here the frequency slot we can just go regarding towards the each and every frequency allocated to each and every band. So whenever you go for the walkie-talkie over there, within that walkie-talkie we can select the number of channel. So this each and every slot is known as the channel. Generally their particular wave will be changing according to each and every channel, and all the police or that particular militaries or navies, they will be just talking in a single channel, like come up or over, are you able to hear. So based on that particular channel, they will be able to talk within a distant range of frequency, like within a city or within that particular kind of region. So for that particular FDMA is being applied over there. So to broadcast a particular kind of frequency signal according to each and every time. So here we don't have any of the time, so we can just access at any time whenever we require. But the power is mandatory. If the power is low while compared to the frequency, then this is directly proportional, as based on the power only the frequency also will be increased. For example, whenever we just provide anything for the LED, so whenever that particular LED will be brighter whenever we provide a full battery, it will be lower whenever we provide a low charge battery. So the same thing only, it will be working for each and every device. So if the power is there, the frequency will be increased. The power is low, according to the power, the frequency will be distributed. Now within that FDMA, we are going to combine even the time. So according to the each slot of time, each particular frequency will be broadcasted. Like if we go for that particular radio system, I have said that radio system works with time as well as frequency, because each and every time has been allocated for the slot of each and every programs in your radio. So to allocate each and every different programs within a single frequency only, we are able to work with time domain with frequency domain. So here, if you are taking only the single frequency as 93.5, so that particular frequency has multiple number of programs, like morning 9 to 9:31 program, then 9:30 to 10:31 program, 11 to 12 one program, then goes with 12:30, and it prolongs according to the interview or whatever the funny kind of thing they will be going on. So here they will be working on with the TDMA with FDMA. So with a rated frequency, they will be able to access the multiple kind of programs. Even we can take the example as our TV. So within this TV, if it is a movie program, it will be for 3 hours, and if it is a normal series program, then it will be for half an hour or 40 minutes, like that. In between, they will be allotting some times for providing the advertisements. So that time slot here it is paying that. So within this time slot, you are going to release this, or else they might have should be found as multiple kind of frequency. So if they go for multiple kind of frequency, then there will be multiple kind of channels. Then that only has bought in a TV. Like we can go with that multiple kind of channels. Like in Sun itself, they have many kind of channels. And if we go for Telugu, or if we go for Hindi, especially Star itself, there are many kind of channels, but all the channels are in different channel numbers. So each and every channel number only they will be setting it as frequency. The same thing only we will be going for the radio also. So if you are going for Red FM, it is particular kind of value. Then if you go for any kinds of local FM, for that there is separate localized channel number, or we can also say it as the frequency. So while combining the time and frequency, the time will be able to divide it equally according to the program, whereas the frequency will be staying as the constant. So in this way only the time domain with frequency domain will be working over. Whereas the time domain can be easily changed by the user, but whereas frequency signal cannot be easily changed by the user. It depends upon the broadcasting or the collection of uh, satellite communication, whatever we approach towards it. But nowadays you might think, so why the YouTube is able to work in this way, whether they are also using the same broadcasting technique and all not. Absolutely, there is no relation between this TDMA, FDMA with YouTube or other kind of devices. They may only use this kind of TDMA and FDMA for TVs and radios, but whatever we are using for YouTube or Prime or Hotstar, it is nothing but known as UDP IP. So within their internet protocol, we were able to apply that user defined protocol. So there within a single time, multiple number of users will be able to access any kind of data. But whenever if we go for the TV or radio, whatever they are displaying, that only we will be able to see. So whenever we go for this kind of YouTube or Prime, like that kind of series, we can select whatever we required from their group of data. So that only make a complete difference regarding towards the protocols as well as the communication systems. Then comes with CDMA, code division multiple access, which also gets combined with the frequency of the signal. So this code division multiple access is used in mobile phones. So what is this code in our mobile phones? Those are none other than our 10-digit numbers. The 10-digit numbers will be standing as the code division, and this particular code division multiple access. So like whenever you make that conference call, or the voice conference and video conference is completely regarding towards internet, so I am not going towards it. Go towards a voice conference call, which is famous for everyone, and it can be simultaneously used by all the peoples at the same time, but only the unique number will be provided to you guys. So for example, I have almost 10 years back this particular kind of mobile number, and till now I am using the same thing. So regarding towards this particular kind of CDMA principle, we will be applying it towards a mobile communication system by interfacing with FDMA. So what this FDMA stands while combining with CDMA, none other than whenever we are communicating towards the people, we will be just checking that signal strength. If the particular person is not able to hear, or we are not able to hear regarding towards that particular person, so it is nothing but completely regarding towards the signal strength. So that particular signal strength only, it is based on the frequency. So this frequency will be integrated towards the CDMA, and this code division multiple access, when a person gets called, based on the signal strength, the data will be able to transfer. So that is known as the particular kind of application. Then comes with OFDM, known as the orthogonal frequency division multiplexing. So orthogonal is nothing but the multiple angle, or known as the 8 angle frequency. So within that 8 angle frequency, we are able to equally divide it like multiplexing. So single input and multiple output. So this single input and multiple output is mostly used for the kind of devices like internet. So through single input, so if you are just able to going for a WhatsApp group, therefore we will be providing only one message, and that message will be reaching widely towards all kind of peoples those who are there in the particular group. So that is just an example. But whereas the 5G has been mostly being implemented only for the internet access, so to avoid the discontinuity of the network till whatever we use. So once we able to use it for discontinuity section, therefore we can directly apply it towards the IoT devices. So therefore we will be able to work with IoT devices as continuous possible, and those devices are also portable from one place to another place. Now also we people are using IoT devices with the help of the Wi-Fi, which doesn't have much range other than the house area or whatever the office area whichever we have been connected. And according to that particular kind of maximum connections, there are limitations. Starts from basically 5 connections can be accepted, and maximum with 30, 40 or 50 connections within a single Wi-Fi modem. Or if they require any other particular kind of connection to be added, they have to add the particular modem within the same organization or their house. So whenever it comes under the 5G, if each and every mobile is connected towards the 5G, then there will be some node for that particular 5G wherever they travel. Therefore, the net connectivity will be continued, and here that particular transmission rate also will be increased. So this is nothing but some statistics of 5G. Like it was planned to release in 2020, and due to this pandemic period as well as the COVID-19, they were not able to release it as they have decided. And it was mostly applied towards the functions of Airtel. I heard that the Airtel is the only communication which has been tested under the 5G, and there are some mobiles that has been currently released which is capable of working with 5G over there. So what are the advantages? Like 10,000 more traffic will be assigned, and which communication will be going on smoothly. It can connect to more than 100 devices at the same time with less than 1 millisecond latency. The battery life of your particular device will be provided for 10 years whenever we are providing for machine to machine communications, and most of the mobile batteries are not lasting more than 4 years. It depends upon the particular users, but among the users, a 10 percentage can be provided towards the network. So communication from one machine to another machine now turns into the low cost, and the data transmission that can be done in 5G is about 10 GB for uploading and 100 MB whenever we are going to the download, because currently we are availing of download speed only at 1 MB per second, or we can go with maximum of 4 MB per second in that range. So the common applications like virtual reality, smartphone, education, cars, smart homes, smart energy, and healthcare will be the most kind of applications where the 5G will be implemented. So these are the different electromagnetic spectrum like static electric, alternative electric, TV, radio broadcast, mobile phones, microwave and satellite, visible sunlight, ultraviolet rays, X-rays, radioactive sources. So below this each and every image you will be able to see the different multiple access whatever has been provided based on their frequency. So those who require it, they can note it down. Okay, so I hope I have noted that particular required things, whatever you need, because this particular spectrum analysis is most important whenever we are getting into the communication oriented functions. Okay, so these are the band exploited areas. This band exploiting areas will be just converted according to the uploading as well as downloading frequency range. So for each and every technology here it has been listed by starting from 3G, and in between you will be able to see some 4G combined with 2G. Nothing but multiple access can be done. So in that particular way also the frequency range has been provided, and at last we have seen that Wi-Fi, Bluetooth range, and WiMAX. WiMAX is nothing but we can say regarding towards the hotspot or the portable Wi-Fi modem whichever we have, like Geo5, that kind of modem. And WLAN is nothing but normal wireless LAN communication, also known as Wi-Fi and Bluetooth. To Bluetooth also internet can also be shared, but only for the required distance, whereas through Wi-Fi we will be able to share in the range of the meters. So this is nothing but a small analytics regarding towards each and every application of 2G, 3G and 4G that has been availed all along the world. So here the 4G indicates as the red, where 3G is indicated as the green, and GSM is indicated as the 2G or in yellow color. So if you guys have any doubt regarding towards this, you can just post it in the chat box. We'll be providing the maximum solution according to your questions. So next we can go regarding towards the cognitive radio networks. So this particular cognitive radio networks, we have just worked regarding towards the radio network analysis provided in a surrounding area regarding towards the map. So each and every place we will be just providing as an cognitive section or the tower network. So within that circular area, it will be able to transmit from one signal to another, and from that one signal to another, we will be able to say it as a transceiver section. So this particular technique only nowadays we are being applied till 4G, and now this OFDM is being applied towards this cognitive radio networks, and from that only we will be able to analyze each and every kind of system. So based on this particular kind of radio frequency system only, it will be transmitting and receiving the entire data. So this will be the particular architecture, like a primary network station, primary network user, secondary network user. So here I can just say it as first you just follow the blue line. So the particular blue line is able to transfer the message from that particular place to the other one. So from one circle radius to another. So what that particular mobile user or known as the primary network user will be applying towards the primary network of base station. So from that it is transferred towards the nearest base station according to the CDMA or the code analysis or the particular receiver whatever the code word have. So it is received according to that particular tower, and once it is received and the data will be decoded, and we will be able to hear whatever that primary person has been said. So in this, based on that particular application only, we will be able to uh, similar or sync the data from one state to another state. So wherever they keep that particular tower, that particular radius is known as the particular base station. So from within that tower, we will be able to make a call or receive a call or send any other data as well as receive any other data. So within a second, around of 82 to 84 calls can be done. with the help of a single base station network. So that is the common fact till now. So based on that particular spectrum sensing, it automatically changes according to the respectiveness of frequency, time and power. So here power is nothing but our mobile charge and frequency is nothing but the strength of the tower. The time is nothing but according to the duration, how much amount of time we are able to call, like 1 hour we are taking to call a person or we are talking towards them, 2 hours. So the time gets automatically varied according to the spectrum of data. So we will be able to see that whenever you record the call, according to the frequency, if the signal is low, there will be some kind of noise, whatever you hear. If the signal is strong, whatever you have spoken will be completely strong. So here we have two different types of radio, like conventional and cognitive. The conventional radio is nothing but whatever we use it in our radio systems, and cognitive, whatever we use it for mobile data transferring, whichever we have seen now. So what this conventional radio is different from cognitive. So in cognitive, the noises or unwanted signals are less while compared to the conventional. So whenever we just set the frequency of the radio, we might find some unwanted noise which will be feeling as an irritation, like grains or no channel proper communication, or due to some rain there will be some kind of interference in network. So that kind of things and all can be easily done in conventional radio, whereas in cognitive radio, during this type of issues the signal gets weakened and therefore we won't be able to call or talk to the person clearly. So this comparison only known as the difference between conventional and cognitive radio. So as I have said, this particular OFDM is orthogonal frequency multiplexing. Multiplexing is known as single input and multiple output. So here also we are applying the same thing only. So for that we have to design an antenna. So that particular antenna is known as the MIMO antenna. The antenna which is capable of multiple input and multiple output of the section. So whenever we go for this particular kind of section, we will be able to work regarding towards the leverage other radios to affect an antenna array. And what is the particular kind of application or good kind of advantage of MIMO is nothing but it can be extended according to our usage. The region or the area of requirement can be extended. Then all kind of combined networks, which is known as mesh network or confused mode of network, can also be analyzed. Then extension of range will be much cheaper while compared to the other kind of implementation. So the most kind of issues we will be facing is timing or portability, then coordination and overhead lines of communication. Yeah, Mr. Sudhakar sir has been put a query that webinar should be occurred at this frequency. Yeah, definitely. So it depends upon the multiple kinds of usage, as it is a work from home and nowadays a study from home. This particular online education, it plays a major role over here. So definitely, not only this webinar, none of the webinar cannot be maintained this particular kind of frequency over there. So it depends upon the number of users. Even though if we try to increase, we will also be increasing and the other guy also will be increasing that particular range. So there is no use of increasing that particular kind of frequency communication. And that is why the assimilation will be working. As today will be the Sunday where multiple offices and multiple schools will be holiday. So therefore, we will be able to stabilize this kind of network. So that is the kind of frequency whatever we speak. So here, whatever the connection I have provided with Wi-Fi as well as the optical fiber. So within that itself, based on the Wi-Fi frequency, we will be able to convey the data at the maximum frequency. So this is nothing but allocation as well as exploitation. Like allocation in the sense in which places that particular antennas or tower should be placed, and exploitation is nothing but broadcasting of data, how that application should be taken place. So in this way only we can say that kind of cognitive radio gets combined with multiple towers or multiple connectivity devices. So here we can see that difference between licensed as well as unlicensed base station. So regarding towards this user, the only change in the sense they will be able to work with a single base station if it is licensed, and if they are connecting with multiple base stations, then uh, nothing but due to the unlicensed system, because whatever the device particularly we are using, like each and every tower, it is placed according to different kilometers. For this particular kilometer, we were able to just place different companies tower are available. That is nothing but regarding towards the unlicensed system. The licensed system, especially in India, it is particularly used only by the defense peoples, like DRDO, then military, and ISRO. So these particular systems only will be using by the licensed, since they require the long range of communication from state to state, or at the same time in ISRO to communicate with the satellites which whatever they have launched. And DRDO is nothing but regarding application of defense research system. So how we can feel that frequency? If the frequency is licensed, definitely they will be having more number of frequency range. And whenever we pass regarding towards this particular area, therefore our mobile phones won't be able to work. And at the same time, whenever we go for the normal, or if we just pass by the normal towers, we will be able to convey our data as easy as possible. So now let us see some demo regarding towards this. So for this app simulation in OFDM, we can just select our wireless waveform generator. So here we will be allocating the signal or channel or the time domain, whatever we require. Yeah, so therefore it has been opened. So here I am just applying the normal OFDM, and the input type for this OFDM I am providing it with the help of QAM or PSK. Both are applicable. If you want to define our own kind of application, that is also available over there. So for this input waveform, I can create the modulation order, the symbol of mapping, and the bit source. So here the bit source I am giving it as 9 bits. So here you can see that Fourier transform has been applied, fast Fourier transform. And regarding towards this transmitting antennas, we have kept only one. So according to each and every modulation, we can change it. And here there are subcarrier spacing of more than 1 lakh. I think it is 10 lakh hertz has been provided. So this complete data, whatever we are seeing, it is the basic standard data that has to be applied over there. So now I will just generate this particular waveform so that we will be able to see that OFDM mapping grid as well as the spectrum analyzer. So according to this data, whatever we have provided, this will be the spectrum data. So this visualization can also be provided with the time scope so that we will be able to compare the real values and imaginary values. It is analyzing with the previous data whatever we have collected. Okay. So therefore now you can see how the real as well as the imaginary values gets compared. So previously we have seen for LTE the same waveform generation, how the real time values and imaginary values has been obtained. So the same thing only we have done with the wireless waveform generator for OFDM, and here we can export it to a waveform file into the workspace directly or in the form of .mat, so that we will be able to analyze each and every data whatever we require over here. So similarly, if we go for that IEEE standard of A bar G section, takes time to convert. So here the basic channel bandwidth is 20 megahertz. So here we have a spectrum analyzer and time scope. The same time scope only we are using. And the packets will be sent as one. A single packet will be generated at each and every time. So with the help of the basic credentials of data, I will be generating the waveform here. So this 802.11, it is commonly for wireless communication, and A bar G bar J, it is used for OFDM technique. So that particular series only is designed by IEEE, which can be normally seen in our modems or whenever we design the antennas according to it. Especially this OFDM, mostly we will be able to see clearly with an good accuracy or efficiency in the coming mobile phones only. Even the some of the mobiles whichever we have also the OFDM, but they have been converted into long-term evolution communication. So if you like this video, please like and share it to your friends. So if you have any queries regarding towards it, you can just post it in the chat box. And at the same time, if you want to just approach towards its Pantech e-learning, so we are currently conducting many kind of webinars through online as paid courses in collaboration with IETE Mumbai and National Institute of Technology Surathkal. So those who are interested to join 1 month workshop, so they can definitely approach us through Pantech e-learning. We also have a online WhatsApp service. Yeah, implementing polar codes, it is definitely difficult. We have to arrange the plot section over there. So based on this simulating data, it is very difficult, whereas real-time data would be more easier. Through comport, we have to get each and every data towards our system. Then we will be able to plot each and every polar codes. Because most of them won't be using a simulation with the help of Python, either with the LabVIEW and either with MATLAB they will be using on. I hope everyone has enjoyed today's particular session regarding towards the 5G communication. So we will be meeting as soon as possible with another one technology. So if you want to contact to join any of the training classes, you can just contact us in this particular number. You can contact towards Mr. Sandil Kumar, Mr. Srinivasan, and Mr. Kumar Swami. Also, you can follow us through social medias. You can also follow us through this particular website, pantechelearning.com. Thank you all. Thank you all. Thank you all for your valuable comments. Please like and share the video. Yeah, welcome, welcome, welcome. Okay, thank you all for your wonderful support, and we will be meeting as soon as possible with a new technology. Till then, bye to all. Stay safe.